आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone. So today we are going to discuss one question on limits. So here in this question we are given that if the function f of x is defined like the tan x upon x like this, then in such a case we need to find the limit as x tends to 0 of this expression. So in the expression we are given that the GIF of f of x plus the x square and this whole is raised to the power of the 1 whole upon the fractional part of f of x like this, where this function represents the GIF function and this function represents the fractional part function. So now for doing this question we are going to take this function which is given to us in the question. So here we are given the f of x. So the f of x is given to us as the tan x by x like this. So now for doing this question we are going to find the limit as x tends to 0 of f of x. So if we find this limit, then we get here instead of f of x we have the tan x by x. So here we have the limit as x tends to 0 of the tan x by x like this. Now we know that as x tends to 0, this tan x by x would tend to 1 plus. It would be slightly greater than 1. So 1 plus means that this value would be the 1.00001 like this. So here we have got the limit as x tends to 0 of f of x function would be as 1 plus. So let us say that this is the result 1. Now similarly here we are also going to use one more identity. We know that if we are given the fractional part of anything, so we can write the fractional part of anything or any function, that is the fractional part of f of x. So this could be written like the f of x minus the GIF of f of x like this. This is also true. So here we are going to name this result as result 2. So now here in this question they have asked us to calculate this limit. So now we are going to focus on that. So here we are given the limit as x tends to 0 of, here we have the GIF of f of x like this plus x square, and here in the power we are given 1 whole divided by, in the denominator we have the fractional part of f of x like this. So now here we have the limit as x tends to 0 of this GIF of f of x. So now we are going to calculate this. So here we have the limit as x tends to 0 of the GIF of f of x. So here we have the GIF of f of x like this, and here from this equation 1 we know that as the limit x tends to 0 of the f of x, this limit when we calculated here is equals to the 1 plus. So here if we solve this, then instead of this f of x we get the 1 plus. So it would be the GIF of 1 plus, that is the GIF of the 1.00001, and it would be equals to 1. So here instead of this GIF thing, as limit x tends to 0, this GIF of thing would tend to 1. So here instead of this thing we can write, here we have the limit as x tends to 0, here we have the 1 plus x square like this, and in the power we have the 1 whole divided by, in the denominator we have the fractional part of f of x. So by using this equation 2 we can write the fractional part of f of x as the f of x minus GIF of f of x. So here we have the f of x minus the GIF of f of x like this. So now again we are going to solve this. So if we solve this, then here we have the limit as x tends to 0, here we have the 1 plus x square, and in the power we have the 1 whole divided by, instead of this f of x we have the tan x by x which we are given in the question, minus the GIF of f of x. So here we know that the limit as x tends to 0, this GIF of f of x would tend to 1 as we have calculated here. So now instead of this GIF of f of x limit we are going to put 1 because this value is equals to 1 as we calculated. Now we are going to solve this, but before solving this we know that here we have the limit as x tends to 0. So this would be as a limit as x tends to 0, this thing, this base would tend to, here we have the x square which is 0. So the 1 plus 0 would be 0. So this base would tend to 1, and as x tends to 0 we know that here we have the 1 whole divided by, in the denominator we have the tan x by x. So as x tends to 0, the tan x by x tends to 1 plus or 1. so it is 1, and here we also have 1, so in the denominator we have the 1 minus 1, that is 0. So here in the power we have the 1 upon 0, so the 1 upon 0 is infinity, so here it is like the 1 to the power infinity kind of indeterminate form. So now we are going to solve this indeterminate form. But before solving this indeterminate form, we are going to solve this limit here. So here we are going to rewrite it like this. So here we have the limit as x tends to 0. Here we have the 1 plus x square. So here we have the 1 plus x square, and in the power we are going to take the LCM. So if we take the LCM, and we are going to write this 10 as sine upon cos. So if we do that, then we get, here we have the 1 whole divided by, in the denominator we have the 10, and instead of 10 we write the sine upon cos. So here we have the sine x upon cos x into x, so it would be the x cos x like this, and here we have the minus 1 like this. So this is in the power. Now if we solve this ahead, then we get the limit as x tends to 0. Here we have the 1 plus x square, and here we have, if we take the LCM, then we get the x cos x in the numerator of the power. So here we have the x cos x like this, and in the denominator we have the sine x minus the x cos x like this. So this is in the power. Now as here we have seen that this limit is like the 1 to the power infinity kind of indeterminate form. So now we are going to solve this limit. So for solving this limit, we have a formula. We know that if we have something like this, if we have the limit as x tends to 0 of f of x whole to the power of g of x like this. So here if we have the as x tends to 0, if we have the limit as x tends to 0, and along with this if f of x tends to 1, and here if we have as x tends to 0, then along with this if the g of x tends to infinity, then here we have the 1 to the power infinity kind of indeterminate form. So in order to solve this indeterminate form, we can have the formula as this limit would be equals to the limit as x tends to 0. Here we have the e whole to the power, in the power we have the f of x minus 1 whole multiplied with the g of x like this. So whenever we have the limit like this, whenever we have the limit in which we get the form 1 to the power infinity indeterminate form, so that limit can be written like the limit x tends to 0 e to the power f of x minus 1 times of g of x, where f of x is the base and g of x is the power. So here we also have the same thing. Here we also have the 1 to the power infinity kind of indeterminate form. So here we are going to use this formula. So by using this formula, it could be written as equals to, here we have the limit as x tends to 0, and this is the f of x, that is the base. So here we write the e to the power f of x minus 1. So here we have the 1 plus x square minus 1 times of g of x, where g of x is the power, that is this thing. So the g of x is power, so the power is the x cos x whole divided by, in the denominator we have the sine x minus x cos x like this. So on solving this we get this thing. So here we can see that this plus 1 and minus 1 gets cancelled out, and if we solve this, then we get the limit as x tends to 0. Here we have the e whole raised to the power, here we have the x square into x in the numerator, so it would be the x cube cos x. So here we have the x cube cos x like this, and this is whole divided by, in the denominator we have the sine x minus x cos x like this. So now for solving this limit, we are going to use the sine x and the cos x expansions. But before that, we know that as the limit x tends to 0, the cos x would tend to 1, because the cos 0 is 1. So as x tends to 0, this cos x would tend to 1. So now we are going to neglect this cos x here. And now we are going to write the expansions of the sin x and cos x. So we know that the expansion of the sin x is given by, here we have the x minus the x cube by 3 factorial plus, and this goes on up to infinity in the expansion of sin x. And similarly we are going to use the expansion of cos x. So in the expansion of cos x we have the 1 minus the x square by 2 factorial like this, and here we have the plus, and this goes on up to infinity in the same manner with the alternate positive and the negative sign. So now we are going to use these expansions here. So if we use these expansions here, then here we get, here we have the limit as x tends to 0, here this e his whole raised to the power this thing. So here in the power we have the x cube. So here we have in the numerator the x cube, and in the denominator we have this thing, the sine and the cos. So now we are going to use the expansion of sine from here. So instead of sine we are going to write the x minus x cube by 3 factorial plus, and this goes on up to infinity like this. And similarly here we have the minus x cos x. So here we have the minus x times of the cos x, and the cos x expansion is this. So we have the 1 minus x square by 2 factorial plus, and this also goes on up to infinity like this. So this whole is in the power. So now we are again going to rewrite it and solve this further. So here we have the limit as x tends to 0. Here we have the e whole raised to the power this thing. So here we have the x cube in the numerator, and in the denominator we have this plus x, and when this minus x gets multiplied inside this second bracket, then it forms a minus x. So here this plus x and this minus x gets cancelled out, and after solving this we get in the denominator we have the minus x cube by 3 factorial here, and from here we have the minus into minus, that is plus x cube, that is the x square into x. So it would be the x cube by 2 factorial. And here we also have some higher order terms, that is the x to the power 5, the x to the power 6, the x to the power 7, and x to the power 8. So we will be having the all higher order terms, but we are going to neglect them because here the x is tending to 0, and as x tends to 0, all of those higher order terms would also tend to 0. So they would be very, very small in comparison of these terms. So here we have got this result. Now from here, if we take this x cube and this x cube common out, then we can say that this x cube gets cancelled out with this numerator x cubes. All of these x cubes have now got cancelled out, and here we have the limit as x tends to 0, and here we have the e whole raised to the power. In the power we have the 1 whole divided by, in the denominator here we have the 1 by 2 factorial like this, and here we have the minus 1 by 3 factorial like this. So if we solve this, then we get the e whole to the power. Here in the denominator if we take the LCM, then we get the 2 factorial into 3 factorial in the numerator. So here we get the 2 factorial into 3 factorial like this, and in the denominator we have the 3 factorial minus 2 factorial. So here we have the 3 factorial minus 2 factorial. So if we solve this, then we get the e whole raised to the power. 2 factorial is 2 into 3 factorial is 6, and in the denominator we have the 3 factorial, that is 6, minus 2 factorial, that is, so the 6 minus 2 would be 4. So here we have 4. So this 2 gets cancelled out with this 4, and this 2 also gets cancelled out with this 6, and we are left with the 3 in the numerator only, and in the denominator we have 1. So on solving this, we have finally got our limit as the e to the power 3. So now in the question they have asked us to find the limit of the given expression and the limit of this given expression. Here we have calculated as the e cube. So this is our solution. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।